Hey everyone, welcome to our last video. Yay, that's so exciting to say. All right, this section is 5.5. So we don't do 5.3 or 5.4 in here. 5.5 is inequalities and systems of inequalities in two variables. So we're back to two variables. Now I want to remind you that inequalities is just when you have less than or less than or equal, or greater than or equal. Now, something to remember is that the less than and the greater than signs, just like on a number line, how we usually write them with a parentheses, we're going to use a dashed line. So we're going to be like graphing these and stuff. So it's a dashed line for those. If it has the equal to bar, then we would use a solid line. And I'll kind of explain why when we do an example. But for the most part in here, we're just going to be graphing lines, and then we will shade our favorable region. So for my example one, I'll just say graph the linear inequality. So part A, we'll do y is less than negative 1 over 2x plus 2. And let me go ahead and draw myself a graph. So since this is a line, we want to first make sure that it's in y equals mx plus b form. That way it's easier for us to graph. If it's not, we can always just manipulate it. So thinking of this as like a normal line, even if it was just like an equal sign. First, we would graph our y-intercept. So my y-intercept here is 2. So I graph that first. And then my slope is negative 1 over 2. So I'm going to go down 1 and then over 2. Now, if you need more points, then of course, do some more points. Oh, I accidentally only went up by 1. Sorry about that. Let me fix my points real quick. 1, 2, here we go. Sorry. I was just kind of looking at my graph. Weird. Now, because this is a less than symbol, it doesn't have the greater than to, I'm sorry, it doesn't have the equal to bar. This is going to just be a dotted line through here. So we don't want a solid line. This is a dotted line. Then you want to shade the region that will have correct answers. So pretty much on either side of this line, we may be able to find correct answers. So either we're going to shade in the bottom of the line and say, oh, numbers below this line work. Or we could shade in the top and say points on the top of this line work. To find out which is which, I usually like to just test points. So first, I'm going to pick a point that is underneath the line. So in this case, let's just do 0, 0. So we're going to test. So if I test the point 0, 0 in the original line, in the original inequality, I get 0 is less than negative 1 over 2 times 0 plus 2. So here I get 0 is less than 2. And since that is true, that means that I can shade this region, and any point underneath this line, all the way up to the line, but not including any points on the line, will satisfy this inequality. That's also the reason that you need it to be dotted, because if I actually plug in one of these points, for instance, if I had plugged in the point 4, 0, it's actually not going to be true in the inequality. So that's why we need a dotted line. We only want to shade below the line. Now you can also test another point just to make sure. So let's test a point above the line. I usually like to use 0 if I can. So let's go ahead and test the point 0, 5. So if I test this, I get 5 less than negative 1 over 2 times 0 plus 2. So it says 5 is less than 2. So that does not work. So that makes sense of why I did not want to shade that region. But I just checked it just to be sure. Let's do another one. So part B, I'm going to do 2x minus y is greater than or equal to 1. So first, this is not in y equals mx plus b form, so I would like to change it to that so that's easier to graph. So I get negative y greater than or equal to negative 2x plus 1. Then I'll divide by that negative. Be careful, if you're dividing by a negative, you have to flip your inequality. So don't forget that. Now I'm going to graph. So my y-intercept is at negative 1. My slope is 2, so I'm going to go up 2 over 1. Now because it is a equal to bar on there, that means it's going to be a solid line. I'm saying that points on this line will actually satisfy this inequality. And now we need to decide, is it points above this line that's going to satisfy or points below this line that's going to satisfy? So I'm going to test a point on either side. Again, you can choose whatever you want to use to test. I'm just going to pick a point. I do like to test 0, 0 if I can, so let me go ahead and do that one. So if I test out 0, 0, and I'm going to test it into the original because that's just my preference. I get 2 times 0 minus 0 is greater than or equal to 1. 0 greater than or equal to 1. That is not true. So that means that that area is not going to get shaded. So I'm expecting to shade the bottom of the line. However, I'm going to pick a point to check just in case. So let's do this one. And again, I mean, you can test whatever point. As long as it's one above, one below, you're good. So this one I'm testing is 3, 0. So I get 2 times 3 minus 0 is greater than or equal to 1. So I get 6 is greater than or equal to 1. Well, that is true. So that makes sense because I was thinking I was going to have to shade this part anyway. So I'm glad that we could confirm it by getting a point that works. Keep going. Let's do another one. Let's do y is greater than 2. So this one, you got to remember how to graph lines a little bit. When you have a y equals on a line, what kind of line is that? It is a horizontal line. So this means we have a horizontal line at 2. Because this doesn't have the equal to bar, it's a dotted line or a dashed line, whatever you want to write. So when I graph this, I have it at 2, and I'm going to make sure that I do a dashed line or dotted line. You know what I mean, I hope. And again, we'll go ahead and test some points. So I always test 0, 0 if I can. The only reason maybe you wouldn't is if it actually goes through 0, 0. So if I test 0, 0, I get 0 greater than 2. Well, that is not true. Let's test something above. Let's test 0, 3. So I get 3 greater than 2. That one's right. So it's the top that's going to get shaded. And I'll just do one more like these. We'll do an x one as well. So let's do x is less than or equal to 3. So first we want to think, what kind of line is this? And this is a vertical line at 3. And it's going to be a solid line because we have the equal to bar. And again, we'll just test some points. So I'll test 0, 0, see if it works. We get 0 less than or equal to 3. Since it works, I'm going to shade that region that 0, 0 is in. But just in case, I do still like to test something on the other side as well to make sure that it doesn't work, since that's what I should see. 4, 0, so I get 4 less than or equal to 3. All right, that does not work. So it makes sense that this side got shaded. Now there is actually a rule that I can tell you so that you don't have to test the points. So if it's a greater than or equal or a greater than symbol, you're going to always end up shading the region above. But let me be careful here. You would need to have the y alone at this point. Because for instance, with part B, you see how it's a greater than, but we didn't shade above. It's because when we got it as the y equals, it actually turned into a less than. So you got to be careful that you get the y by itself before you make that decision. If it's a y less than or y less than or equal to, then you will shade the region below your line. And then for the x one, it's kind of the it's almost like the opposite of what you would think. So you got to think like on all of these, you're going to see x on this side of it, plus or minus some other stuff. So for our x, since it was a vertical line, we actually ended up shading to the left of our line for our problem. Now, I think you should just check points, to be honest with you. That's my preferred method for doing these because I just think it can be so easy to forget, like, oh, if it's greater than or equal to, am I supposed to shade below or am I supposed to shade above? You don't need more stuff to remember than y'all already have. You already have so many formulas and everything to remember. I would just go ahead and test points, but it is totally up to you. Now we can also see nonlinear inequalities. I don't believe the homework really shows you any of these, but we can see them. So for instance, let's do y is greater than x squared. So I'm just going to graph it just like y equals x squared. So if I plug in some points, I get 0, 0, 1, 1, negative 1, 1. So this is just a parabola, but it would have to be dotted or dashed because it doesn't have the equal to bar. And for my points, I would test one below the parabola and one above the parabola. See, this one I can't test 0, 0 because it's actually being like it's on the parabola, so it's not a good point to test. So let's see what I picked. I picked 2, 0. So let's choose that one and see what happens. I get 0 greater than 2 squared, 0 greater than 4. That is not true, so I'm not going to shade underneath the parabola. I should expect to shade above, so let's see what I get there. I get 0, 2. So this would be 2 greater than 0 squared. Well, 2 is greater than 0, so it makes sense that I would shade inside or above the parabola. So these can be nice to just practice some more types of graphs. Let's do, if I do y is less than log base 2 of x. This is nonlinear as well. So remember, I'm just going to graph this like normal. So if I was looking at y equals log base 2x, I'm basically graphing it just like I would do that. So first, I like to change them into an exponential. And then I pick y values and plug them in. So if I do 0 as my y, I get 2 to the power of 0, which is 1. If I do negative 1, I get 2 to negative 1, which is 1/2. If I do positive 1, I get 2 to the 1, which is 2. So I'm going to graph all my points. Now I kind of already know what it looks like, of course, so I feel good with just 3 points, but if you need more, you can plug in more. This is a dashed line. And remember, there's an asymptote, so you don't want to go over that asymptote on there, which would be x equals 0 is the asymptote. And now we can test points. So if I test something on the outside, let's see what I would get. So I get 0 is less than log base 2 of 0. Well, I can't do log base 2 of 0, right? It doesn't make any sense. It's against the domain. So of course this one doesn't work. Now let me test something on the other side. This one is 3, 0. So I get 0 less than log base 2 of 3. Well, maybe that one wasn't a wonderful one to plug in. And that's fine. We can always just plug in another one. I'm saying because log base 2 of 3, if you don't know it, so maybe it would be a little hard to plug that one in. Let's do 4, 0. So if I plug in 4, 0, I get 0 less than log base 2 of 4. Log base 2 of 4 is 2, so this one is true. So that means I am shading this side. And we should have been okay with the 3, 0, but I'm just saying if you plug in something that doesn't really work for you, like you're having trouble figuring it out, you could just always pick something else. The last type that we'll talk about in our video is graphing systems of inequalities. So this just means we're going to have multiple lines to work with, and we're going to have more regions to work with. So this is x plus 2y less than or equal to 4, and then y is greater than or equal to x minus 3. So I'm just going to graph both of my lines first. So for my first one, I need it in y equals mx plus b first. So I have 2y less than or equal to negative x plus 4. Divide by that 2, so I get y less than or equal 1 over 2x plus 2. And now I'll go graph it. So I have plus 2 minus 1 over 2 minus 1 over 2. Is this the same one I did earlier? Just about. But this one has a solid line. Then I'll graph my other line. This one is also solid. So negative 3 is my y-intercept. And then I'm going up 1 over 1. Up 1 over 1. Up 1 over 1. My graph is a little off, but that's just because it's my terrible drawing. But we have a line going through here. That'll work. So now what we can notice is that we just have more regions to test. Now what you can do is if you remember which one is which, like If it's greater than or equal to or greater than, then you shade above. And if it's less than or less than or equal to, then you shade below. Did I say that right? Yeah. See, even I forget them sometimes. So for this one, since my pink line has a less than symbol, I'm going to shade below that line. But since my green has a greater than symbol, I need to shade above that line. So the only area that is below the pink but above the green is this area right here. And so that is one way to do this problem. But if you forget when to shade below or above based on the direction of the symbol, we can always just test points, and that's fine. So I like to do that. So I'm going to test 0, 0. I wanted to use a different color. So first I'm testing 0, 0. Because I kind of always test that one first. And you have to test it in both. So for your first equation, if we test 0, 0, we get 0 plus 2 times 0 less than or equal to 4. 0 less than or equal to 4. So that one's good. If we test it in our second one, we get 0 greater than or equal to 0 minus 3. 0 greater than or equal to negative 3. That is also true. So we would say, yeah, we're going to shade that region. I would still check the other ones just to be sure. So any other point anywhere else shouldn't work unless it's like directly on the line. So let's just try some other ones just to show you what that looks like. Above, let me pick this one right here. So that's the point 3, 0. So I'm going to plug that into both. So for my first equation, I have 3 plus 2 times 0 less than or equal to 4. So I get 3 is less than or equal to 4. That is true. And if I plug into the second one, oh, y'all, I did something silly just now. Sorry, I guess it's this, it being the last video, you know, I'm ready to be done, or maybe I'm getting to, I put my point backwards. That's the point 0, 3, not 3, 0. That would have thrown us off because 3, 0 would have worked. Plug in the right points. So I get 0 plus 2 times 3 is less than or equal to 4. I get 6 less than or equal to 4. That is not true. So that means that region is already out. I don't even have to test it in the second line. Let's see if I test over here. You'll notice that I like to do the X or Y axis if I can. It's just because anytime I can plug in 0, that'll be nice. So I try to. So I'm plugging in the point 5, 0. So let's see, I got 5 plus 2 times 0 less than or equal to 4. That is not true. So that is not going to get shaded. And if I try one more, let's do this one down here for my last region. So this is 0, negative 5. And I'm going to test this point, see what I get. Negative 10 less than or equal to 4. That one works. But if I plug it into the second equation, I get negative 5 is greater than or equal to negative 3. That is not true. So that region does not get shaded. So that is pretty much it. I'll go ahead and make up just one more of these that we can do. So part B, I actually only had one in my notes, so I'm completely making this one up. So we'll see how that goes. Let's do 2x minus y is less than 3. And then we'll do y plus 4 is greater than or equal to negative 2x. I'm just making something up. Since I've already done one, you should pause the video and try to do this one yourself. So for my first line, I'm going to do that one in pink. First, I need to change its form. So I'm going to do negative y less than negative 2x plus 3. Still not quite the form I need. I need y by itself. Be careful. I have to switch the direction of this sign here. So I get y is greater than 2x minus 3. Now I can graph up 2 over 1, up 2 over 1, something like that. And it needs to be a dotted line. For my green, I'll do y greater than or equal to negative 2x minus 4. So negative 2x, so I'm going to go up 2 and then over 1 this way. For this one, it's a solid line, something like that. And now I'm just going to go through and test a bunch of points. So let's try 0, 0 because I love to try 0, 0. In my first one, I get 0 minus 0 less than 3. 0 less than 3, that works. In my second one, I get 0 plus 4 greater than or equal to 0. So I get 4 greater than or equal to 0. That also works. So this is going to get shaded here. I can't believe I made one up that also worked for 0, 0. That doesn't always happen. Still try out the other ones just to be sure. However, it does make sense since both of them were greater than. So greater than says that you shade above the line. So we ended up shading above both of our lines. So it does make sense. But I would still go and pick other points just to be sure. So maybe for other points, I would do maybe 3, 0. Maybe this one over here, which would be, can't read where my line is. It'd be negative 3, 0. So you could try those. And then down here, I would pick maybe 0, negative 5. And so you could go and plug those points in, and they should not work for both lines. But that is really it for this video. If you have any questions at all, please reach out to me. Because this is the last video, this is the last video before your test 3. And so, of course, if there's anything, please let me know. I would love to help you. And I almost was about to say I'll see you in the next one, but I won't. This is the last one. But I do hope